Hello everyone. Today we'll see the working of the basic building block of an artificial neural network called the perceptron. So perceptron, as you all know, is the basic block and it is highly inspired from the biological neuron. Let's first see how a biological neuron works. Let's assume you're looking at a picture of an animal. Let's assume a dog in this case. So our brain looks at it and takes different inputs like if the animal has fur, the shape of the animal, by looking at the eyes of the animal. This information is then processed in the nucleus and then is then transferred to the brain. This is exactly what happens in the artificial neural network. Let's take the same example of the dog image and we try to input this to the perceptron. This will take the different inputs and is then processed, and it tells the computer or the system that the image is that of a dog. Now let's see the inner workings of a perceptron and how it actually decodes stuff. So the first layer or the input layer, the name as it says, is a place where we input all the features. The features could be anything like the shape of the dog, or if the animal has fur, and things like that, and things like if it has a tail and stuff like that. These are then multiplied with weights. Well, you can think of weights as how important the feature is to the perceptron to understand it. For example, let's take fur. Almost all the dogs have fur, so we can say that W1 is highly important. Let's take another input X2 as the color of the dog. Now, dogs come in different colors, like you can see white dogs, black dogs, and gray and different colors of dogs. So, for the perceptron to know that if it's that the image is dog, the color isn't a great option. Hence, W2 is going to be little lesser than W1 and things like that. Once all the input weights are assigned and all these are then summed up, you can see the mathematical formula here. So all the inputs and these are all the weights, and these are then summed up to form this mathematical equation. Now the next part of this is to send it to a nonlinear activation function. Let's quickly see the differences between a linear function and a nonlinear function. In a linear function, the output y and the input x are in linear nature. That is, you only see them in a straight line. Whereas in a non-linear functions, the input output curves will be smoothed out. The reason why we choose non-linear function is this replicates most of the real life data. Let's take a small example. Imagine you're plotting the data of a person's height with that of his age. If you plot the data, you will notice that as the person's age increases, his height increases. But when he's like 15 or 16 or something like that, the height doesn't increase as much. And once he touches an age of 20 or something, the height is usually constant. So you can see that most of the real life data actually is curvilinear in nature instead of linear. That's one of the main reasons why we use an activation function and try to make this a non-linear output. So as you can see in a perceptron, all the inputs are put into a nonlinear function, and this helps in predicting the output, where in this case the image of a dog. Thank you.